see an image called the Pillars of Creation, people call it. That's my work. That's the kind of stuff that I have done. And then some years ago, you get one go at this, and it was time to do something different, just to have fun. So I left that, and these days I'm a professional coach. I work with executives, professionals, organizations as thinking partner, do some speaking, so on and so forth. And it's in that context that I really started thinking seriously about COVID back in March, because I was working with a school that was starting to think about the consequences of it. Personally, my wife is an elementary school principal in Arizona, public school, Title I public school. We have a couple of daughters who are teaching in the state. We have grandkids going in the state. We have a 10-year-old daughter at home now that is going in the state. And then I've been involved in public education my whole life. Among other things around here, I chaired a couple of school bond committees, building schools, that stuff. I've organized taking people off to the Capitol building to protest. So with all of that said, when I look at education and COVID, I see all of that come together, and I am terribly concerned. And the reason I'm terribly concerned is that COVID is new. COVID is poorly understood, even by the experts. Our understanding of COVID is changing day by day. The public is kind of getting a firsthand front row seat to how the sausage of science is made, with competing claims coming out and people arguing over them and saying, here's these data, and here's these data, and here's these data. And in the midst of that, people will hear things that they like and latch on. Oh, it's okay. See, kids don't spread COVID so much. Oh, this is okay. And so what I would like to do today is I would like to, first of all, I'm a numbers guy. I'm an astrophysicist. What can I say? I would like to talk a little bit about how to make sense of COVID. And then I'd like to talk a little bit about some of those issues like children and COVID and their consequences. So with that said, am I able to share screen now? Let us see.
Yes.
Oh, I think I
made
am.
you a co-host. Okay?
Fantastic. Okay. Science and engineering triumphing over ignorance and superstition, as a guy that I used to work for was fond of saying. Okay, you got it? All right. So everybody out there has seen pictures like this day in and day out. You follow them, you see all of these numbers. This is Arizona. And apart from the numbers, what does it mean? What can you actually learn from these things? And since I'm an astrophysicist, clearly the right thing to do is to start with the set of differential equations that are used to, and you'll notice here that the time derivative of the susceptibility, and no, actually, that's not what I'm going to do. I could do all of that. It's actually kind of interesting. It turns out the mathematics of epidemiology and a lot of the mathematics of astrophysics are remarkably similar. But you don't need that to be able to look at these data and get some sense for what they mean and how to read these and see them. And so I'm going to take a few minutes and just go through, when you look at this stuff, what does it mean? First concept, very quickly, reproduction number. You've heard it. Idea of the reproduction number is fairly straightforward. The reproduction number tells you how many people an average sick person, a typical sick person, gives it to. So if the reproduction number is equal to 1, that just means that I give it to one person, and they give it to one person, and they give it to one person. And so when you see something that's flat in these numbers, that means you're looking at a reproduction number of 1. If the reproduction number is greater than 1, now I'm guessing that there's some of you out there who remember the old commercial, the actress selling shampoo, and she says, I told 2 friends and they told 2 friends, and so on and so forth. And what happens then, of course, is the number grows. And so if the reproduction number is greater than 1, then the number of cases increases with time. And if the reproduction number is less than 1, I give it to half a person, they give it to half a person, whatever, and it tailors away. So this is all about the reproduction number when you talk about what's going on with this. And of course, I'm sure there are some geeks out there somewhere, so I feel duty bound to point out that in the simplest case, that's what the mathematics of reproduction number looks like. And now I will move on. So what can we do with that? Well, that's the reproduction number. The next thing that you have to grapple with COVID, and it's actually one of the hardest things in a practical sense when trying to deal with it, is the fact that COVID takes time. It's slow moving. So for example, here's Virginia. I think it's kind of fun that in some respects, the COVID curve in Virginia looks a tremendous deal like the state itself. I don't know if that was orchestrated or here's Carla chuckling. Yeah. The first question when you look at this is, when did it happen? What are you seeing? And it turns out that when you see the cases that appear today, you are seeing history, because a case that was counted in one place, a case that was counted here, actually was someone who was infected back here. And on average, that time gap is about 2.5 weeks. So it takes time because you get it, you're infected, and then you go for a while and you're asymptomatic and the world is fine, except you're still contagious. And then you start feeling crummy, and then you go for a while before you finally get sick enough that you go in. And even after you're tested and maybe you're in the hospital, it still takes time to get those numbers reported, such that on average around the nation, there's about a 2.5 week lag between when you get the disease and when you actually show up. So when you look at these things, remember that you are looking at history rather than current events. So you could very loosely say, if these are what the cases look like, these were when the infections were back here. Now, one consequence of this that makes decision-making with COVID really hard is that we are ignorant about what is actually happening now. In fact, we are ignorant about what has been happening for about the last 2.5, 3 weeks, really, because of this delay. And not only that, if we do something, we're not going to see the consequences of what we do for another 2.5 weeks or so. So we're in a situation where we are trying to react to the situation as it was half a month ago, and we're not going to know what happened because of what we've done until half a month from now. And in that kind of a situation, trying to hurry things is a recipe for disaster. And as we see, we've seen that disaster all too many times at this point. So the first question again is, when did it happen? The next question is, what happened? So this is now Arizona, and Arizona has the very dubious distinction of being the place on the planet that has more COVID running around than any place on the planet has ever had, and it's only continuing to rise. So I look at some of your guys' numbers out there, and I'm wondering if you've got a house down the street that I could just move to. What happened? Well, again, when you look at what you see in the reports, those are the papers that show up in statistics. And so here in Arizona, for example, clearly something happened there. We were cruising along like that at a reproduction number a bit greater than 1, and then boom, it just takes off. So how do you interpret events like that? Well, the first thing you have to do is remember that what we're seeing here is actually infections that occurred here. And so the event that we're talking about didn't occur here. That event occurred back here. And in the case of Arizona, if you look back here, it turns out that sure enough, that's when restrictions were lifted. And so you get to the point that you can look at these things, you just think back 2.5 weeks, you say, what was going on then? And you can say, that's what was happening. In Arizona, I'll point out that a couple of weeks ago, it was decided that communities could put mask orders in place. Tiny little thing to do. Don't get me started on Governor Ducey. But we have no clue as yet as to what the actual consequences of those have been. So if we were doing really good, effective distance learning here at this point, I would be interacting with you and we would be doing formative assessments as I showed you things and had you work through them, but we're being old fashioned and I'm just talking at you right now. So we'll go ahead and do that. Here's New York. You look at New York, how do you interpret what you see? Well, first thing you do is you say, I'm looking at what happened 2.5 weeks ago. Sure enough, what you see is here, back in early March, infections were going through the roof. The reproduction number was maybe something like 6.7. It was high. And then clearly something happened right here. And what happened right there is Cuomo locked down New York. So there it is. You can see it. You didn't see it in the numbers until 2.5 weeks later, but that's when it happened. After that, the number of cases declined. And what you see here is just a simple exponential decline with a half-life of about 2.5 weeks. The thing I want to point out here is that what's happening is 2.5 weeks go by and the case numbers drop by a half. And 2.5 weeks go by and the case numbers drop by a half. And 2.5 weeks go by and the case numbers drop by a half. That shape of the decline, which is this slow decline with a long tail, is how it works. So there's no such thing as just having all of that go to zero quickly. You just have to wait this thing out. Here's another example. This is now looking at the United States minus New York and New Jersey. And if you really want to understand just how awful a thing we have done to ourselves, this does it. Again, you look at it. What's the first thing you do? You think back in time. So there's where the infections were occurring. Sure enough, early on, you had growth. And then the growth suddenly turns into something that's level. Something must have happened right in there. Well, the thing that happened right in there was when we started having piecemeal shutdowns around the country. So sure enough, they flattened things, but they only flattened things. They took us to the point where the reproduction number was 1. It was just a flat, same number of cases day after day. Nothing was changing. And then you look here and say, that's where the infections are. Gee, I wonder what happened there. Oh, yeah, I forgot to say, just to provide context, if you remember Liberate Michigan, then we're talking about Liberate Michigan time here in the midst of that. This is where the reopenings were. And sure enough, as soon as we started reopening, there go the infections. And then we saw the reported cases later. And again, there we were at R greater than 1 growth, and we have no idea what's going on there. Right now, people talk about, oh, we are seeing over 50,000 cases a day. The reality is we are probably seeing 70 or 80,000 transmissions a day already. And when you look back, by the way, at that period in there, that is a wasted 2 months that had we shut down the nation the way that New York was shut down, it would have saved us. Let's look what would have happened. And I'm literally going to take the this is not a made up curve. This is actually what it would have looked like had we done what New York did as a nation at this point. During those 2 months, people died. The economy took a huge hit. Tremendous amounts of money were spent, so on and so forth, and we accomplished nothing. If we had actually shut down, we would now be at a point where, like Europe, we could be opening up in reasonable fashion. So anyway, that's just kind of a glance at how you read these things. And that's important because across the nation, you guys see these data and wonder what it means for you. It is not difficult to make sense out of it once you have a few of these concepts in mind. And then you can listen to your governor give a news conference like ours did yesterday, and you can sit there and twitch at how wrong he's getting things. Anyway, with that said, and here it's kind of a shame, I'm going to move people over to the upper left corner from the upper right corner so that maybe you can see this a little bit better. I'm not going to go into detail here, but what I did was I took the ideas that I just went over and I asked the question, all right, if we take what we know about the fraction of cases that are typically detected, if we put in this lag time, if we assume that what the growth that we see from the last couple of weeks is representative of the growth that we're still seeing, so on and so forth, you can actually estimate what fraction of the people in my state are contagious right now. And that is of crucial importance to educators, clearly. So, for example, in Arizona right now, we are at something like 3.3% of the population is infectious with COVID, is the estimate. There are independent estimates that agree with that, which means that if you open a campus of 1,000 people, you know right out of the gate that probably something over 30 of them are COVID positive and are contagious. And most of them are asymptomatic, which means you can take their temperatures all you want and it's not going to make any difference. The other thing, and there are other places that are much better. Again, I hate to do the politics thing, but red here are states that were Trump in the 2016 election. Blue states were Clinton. And as you can kind of see right now, the red states are really getting the short end of the stick as far as this goes at the moment. The other thing here is showing how fast things are growing. And this is just over the last 2.5 weeks by what factor have cases gone up. So again, here we are in Arizona. Over the last 2.5 weeks, the number of cases has gone up by about a factor of 2.3, which means that not only do we have more COVID cases than anybody in the world has ever had, but they're just, through the roof. If anybody from one of these other states wants to overtake us and reclaim that title, that would be fine with me. All right. I'm going to leave this one up there for a minute because this shows how you can actually get some data that are now of real immediate impact for you folk. And again, these are just rough estimates. They're uncertain. Some of these are probably pretty good, some much less so. But if you're just kind of interested in where your state stands, there it is. The first number there is how much you have grown over the last couple of weeks, which gives you a sense of the trend in your state. And the second number is right now what fraction of your state is likely to be infectious. So if you're thinking about what's going on in your state, if you just take the number that you see there in percent, multiply it by 1,000 for kind of a 1,000-person campus between students and faculty and staff and all that, and you've got an idea of where you are. So hopefully that's some, at this very moment, honest to goodness, useful information that a week from now will be different because this thing is changing. But you can actually get information out of this that's useful in decision making. Okay. All right. And with that said, I'm sure that we will have some questions about that later. But with that said, I now want to talk a little bit about children and COVID in the community. And with that, I will actually stop my screen sharing. The reason I put this up here is the statement is that COVID-19 disorders, serious disorders, in this case, brain disorders, are being seen in people even with mild coronavirus symptoms. There's some scary stuff going on out there. For example, the cells that are responsible for making platelets that cause clotting in your blood normally are found only in the bone marrow and I think to a certain extent in the lungs. Those cells are now being found throughout the body in COVID victims, even those that are asymptomatic. They're producing platelets. They are causing clotting. They are seeing in autopsies, they'll look at a brain and the brain will be just full of these microclots that had been cutting off oxygen supply to various parts of the brain. That's not what killed the person, but that was a process that was going on. There are lots of other processes that were going on that we just don't know about. And so if somebody tells you, oh, gee, kids are asymptomatic, we don't know what the long-term consequences are. And there is every reason to imagine that there will be long-term consequences. Kids spreading COVID, another thing. Pick up the paper, you'll see people claiming, oh no, kids can't spread COVID, kids have mild cases, kids this, kids that. Those make nice headlines. What don't make quite so nice headlines are the researchers out there going, well, actually, wait a minute, because. So for example, kids are 1/3 less likely to be able to spread COVID than others, is a claim. Yeah, but they're 3 times more likely to have contact with others. So, one might imagine those things level themselves out. Kids don't really have the disease that much, except if you take kids and actually look at the viral loads, look at the amount of virus they're carrying around, what you find is that kids carry as much as adults do. If you start looking at examples, oh man, a long list of these. Upstate New York, there was a situation where there started with a child in a daycare type setting that became a super spreading event that affected 16 people, including kids who had carried it home to their families, and so on and so forth. If you look in Montreal, there was a situation where there was a classroom with only 11 kids in it, in a country where they had done things right, and a kid comes in with COVID, and before they know it, I think there were like 11 or 12 kids and adults that had it. Here in Arizona, a thing called the Arizona State Academy, which was a live-in school for boys. They were kept there. They were doing everything the way they were supposed to be doing, abiding by all the rules. 23 students and 8 staffers later, they realized, gee, maybe these kids can spread it. A live-in girls' school in Prescott, Arizona. I'll stick with, pick a state. There are these examples. 42 students and 12 staff. In Oregon, the problem is they don't test kids that much. In Oregon, they found themselves doing some testing and came to realize that in Oregon, the demographic that had COVID growing most rapidly were kids under 10. Okay. For teachers, yeah, I should probably mention that there were 3 Arizona teachers this summer who were doing teaching online, but they were getting together to do programs together. Everybody thinking they were being very safe. All 3 of them came down with it. One just died. So that is, in fact, the reality. So when you hear people say kids can't get it, you don't need to worry about kids, so on and so forth, you are hearing wishful thinking. There is some indication there may be less likely to spread, but there are many, many examples where, okay, no, they can spread, they can be super spreaders. You have